Hello friends, welcome back to Byte Discovery. This is episode 3 of Learning Git Internals. In this episode, we'll try to create a Git repository from scratch by using only internal Git commands. I'll also add links to all the resources in the description. So let's get started. Before continuing further, let's do a quick recap of what we have learned so far. Git stores the information about the working tree in form of binary objects, and these objects are of three types. The first one is a blob. A blob is nothing but a SHA-1 checksum of the file contents. The next in the list is a tree. And tree represents the directory structure of our working directory, of our working repository. This is also represented in SHA-1 format, and it holds additional references to other trees and blobs which represent the current working tree. The next in the list is a commit object. Commit object is also in SHA-1 format, and it represents a snapshot of our repository at a given point in time, let's say T1. It holds information about who was the committer of the repo and author of the repository. It also includes some timestamps. It additionally holds information such as the commit message. It also points to the tree of the current snapshot, and additionally holds information about the parent commit ID if it exists. Next, we talked about git cat file command to inspect these binary objects. Git cat file command supports two flags, -p to show the content of the binary object and -t to show the type of the binary object. Next, we talked about working directory, staging area, and the repository. We start our work by creating file a.txt and b.txt in the working area. At this point, all our changes are uncommitted. To add them to index, we issue a git add command. This will move our modifications to index area. Finally, we can permanently save our changes to the repository by issuing a commit command. When we do a git add, it saves our blobs inside the objects folder. When we do a git commit, Git also creates a commit and the tree objects. Next, we talked about how to inspect the index by using git lsfiles command. Lsfile command supports two flags, debug to get more information and stage. Finally, we talked about branches. Branches are nothing but a named reference to a commit. At any given point in time, head represents the current active branch. For example, when we create a repository, at that point in time, the head points to refs heads main. At this point in time, we do not have any files and no commits. So head points to nothing. Let's say we add two files a.txt and b.txt and then commit. At this point in time, head again refers to refs heads main, but at this point in time we have created a new commit, so this will point to the new hash commit. So in this case, the current active branch, which is main, points to the commit this. Let's see if we create a new branch. Let's say we create a branch called test. At this point in time, the head will now point to refs heads test, and since this branch is created from the existing branch, the commit hash will point to this. Let's say we add a new file called c.txt. At this point in time, the head on the branch test again points to refs heads test, but the commit will change to a new commit, say 0912 something something. And at this point in time, the test branch, which points to refs heads test, will now point to the new commit. Now that we are done with internal Git basics, we can move on to our next topic. We will create a Git repository from scratch by using internal Git commands. Let's see how we can do it. Alright, so we start with creating an empty Git directory. At this point in time, we are inside the Git-3 folder, and as you can see, this is a completely freshly created folder. Now, in order to start working with Git, let's start by using git status command as our helper. And at this point in time, Git says that it is not a Git repository. Okay, so let's start by creating a .git folder. And if we do a git status, it still says it's not a Git repository. Perfect. Now we know that a Git repository should have certain files and folders inside it. So let's start by creating those folders. The first one that we know of is the objects folder. And let's see if that changes anything. No, Git still says it's not a Git repository. All right. The next thing that we know of is a heads file. So let's try creating that. Git status, still nothing. All right. Now we also know that git head actually points inside refs heads main folder, right? So let's assume we are on a test branch at the moment, and corresponding to that there should be a refs heads test file in our git folder. So let's do that. So we start by creating make dir git refs heads and a file called .git refs heads test. Alright, so we have created a head file, objects folder, and refs heads git, a test. Alright, let's see what git says. Still, git is not happy. And we also know that a head contains reference to the current active branch. So let's see if that can help us. So if we just echo ref as refs heads test to git head, let's see. So now git understands that this is a valid .git folder and it is happy. Now let's start by creating a few files inside our working tree. So we can say echo 11111 to a file called 1.txt, and let's also create a folder and a file 2.txt under it. And we'll save it to the folder /2.txt. All right, let's say what does git say at this point in time. And git tells us there are untracked files 1.txt and the folder called folder. Right. Now we know that when we add files to our index, Git actually starts creating few objects that are stored under the object directory inside your Git folder. So let's see how we can do that. To do this, Git provides us with an internal command called git hash objects. Right. So let's see how to use it. And here you can see we are piping this echo command to the git hash object, and we are asking git hash objects to read from standard input. And what this will do is give us an SHA-1 hash of this content, which is 1234. Right. So now we can see that this hash is created, but this is still not stored in objects. And for that, we have to pass in an additional flag -w. Or we can do something like this. -w and directly the name of the file. And here we can see a new blob object is created. Let's do an inspection using git cat p, and it shows our content. And if we do a -t, it shows us that this is a blob file. All right, let's also commit our file called 2.txt. Perfect. So now we have two blob objects inside our objects folder. Let's say what does git status say. And now git status still says that these two files are, even though they are under the objects folder, they are still untracked. And this is because we have not updated the index tree yet. So let's see how we do that. Git provides us with yet another helpful command called git update index. And let's see how do we use it. So we say git update index. Let me just shorten it. All right. So git says this command is called git update index command. We have ---- add flag, which will add it to the index. we provide additional information called cache info, which is nothing but the type and the permissions on the file. And by default, this is the file permissions that goes for all the objects. Now what we need to do is we need to provide it with certain hashes. So first hash corresponds to the file 1.txt. And we need to do something similar for our file folder /2.txt. Let's do a git status. And here it says that these two files 1.txt and 2.txt are now part of the index. When we do a git add, what it ends up doing is it writes the blobs as well as the tree to the objects folder. So let's see how we can write this tree to the current objects directory. And for that we have a simple git command called git write tree. And this does not take any flags, so we can just write git write tree, and then it gives us with the tree ID which was just created. Let's check this. Right, so it says it has two entries. One is a blob called 1.txt. Let's inspect that. Of course. And the second one again is a new tree. Which in turn creates the blob which points at 2.txt, and we can quickly check the contents of that as well. Right. We still need to write our commit to the objects folder, and for that Git provides us with another command called git commit tree. So let's see how we can use it. In order to write a commit, we also need a commit message, and that we can do in conjugation with git commit tree command by saying echo initial commit and pipe this to git commit tree and the tree that we got in our previous step. Let me also copy it. Right, and here you can see 3958 this git cat file shows the status of our commit. Perfect. Now if I do a git status, it says there's still the index is not clean, right? And why is that? The simple reason for this is now the head points to this file, and let's see what is the content of refs heads test. And this is empty, and what we need to do is we need to put our current commit hash inside this particular file. And that we can do by just simply echoing this to git refs heads test. Perfect. And now you can see this at this point in time, git points to this head, which points to refs heads test, which points to this commit hash. Let's see what git status say. And now git status is happy. Let's see what git log tells us. And it says there was an initial commit made with this commit ID. Perfect. Now let's try to simulate the process of creating a new branch. Let's see how we can do it. In order for a branch to be available, it has to have a file, corresponding file under the heads directory. So let's do that first. Touch, and let's call our branch feature1. Perfect. Let's check the content of this file. This is empty. And since we have branched off to feature1 from the test, it should have the same commit as test. So let's just echo that exact hash to feat1. Perfect. Let's check what does git branch say. It says we have two branch, feat1 and test, but we are currently on test branch. And we can do that, change our branch by simply changing the head. So echo ref to be refs heads feat1 to dot git slash head. Perfect. And here if we do git status and git branch, this confirms that we are on branch feat1. Perfect. Now let's try to add a few more files to this particular feature. So we can say echo 3333 to a file called 3.txt and do a git status. We'll have one untracked file. Perfect. Let's write it to the objects folder, and here we would say 3.txt. Perfect. And this is the hash corresponding to this file. Perfect. Next, we want to update the index. So to do that, we can just say git update index, everything being the same. The new hash and 3.txt. Perfect. Git status will say that we have a new file in our index called 3.txt. Let's write the tree to the objects folder. Nice. So we have the tree ID, and the final step is echo new commit and pipe this to git commit tree with the tree ID this and the parent commit ID corresponding to the previous commit, which was this. Perfect. Let's check the status. Yes. And now what we need to do is echo this specific commit ID to our .git slash refs slash and let's do a git status which says it's a clean directory, and let's do a git log which now shows us both our commits. The one, which was the previous commit, and the next one, which was feat1. So to summarize, we have talked about 4 new internal Git commands. The first one is git hash object command, which is used to write blobs to the object directory. Next, we checked the update index command, which is used to update the index tree. Next, we saw the write tree command, which writes the correct index to the objects folder. And finally, we saw the commit tree command, which writes the commit to objects folder. I hope this exercise has given you some more context on how Git works internally. Now, with this basic knowledge, we have the required tools to explore more advanced Git features, which we'll cover in the upcoming episodes. I will update the description with additional resources. See you guys in the next episode.